Question 5 is about the interstitial atom radius. So the BCC iron is given, and the radius of an iron atom is given, and the interstitial that will not cause any lattice distortion, that the radius of that atom is asked to us. So, and the interstitial site for the BCC atom is given. So let us draw a BCC unit cell first. This is Z, this is X, and this is Y. Again, we have our corner atoms and one center atom. I'm not drawing the corner atom at the origin. So in the question, it is said to us that the location of the interstitial site is at the center here. It is given us as 1/2, 1/2, 0. So half of x, half of y, and z equals 0 is the center of the bottom plane. So in order to find the dimension of this, we draw another cube sitting just beneath it. Since this is a crystal, the crystal continues in all dimensions. So to the right, to the left, again. So the entire structure is made up of cubes, and they continue in this direction, towards you, away from you. So we can draw two cubes side by side. So in order to find the dimension of this, we draw the body atoms again. So from the geometry, the interstitial atom that will not cause any lattice distortion, meaning that these dimensions will not change, must be either just touching the body atoms or smaller than that. So if we draw this is one body atom here, this is another body atom here, and the largest radius that you may have is going to be this. It's just barely touching these atoms, not pushing them or not causing any distortion in other directions. So first we need to find what this distance is between these two body atoms. So since this is at the center of the body and it cuts the z direction into 2, this is going to be, from the top it's going to be a/2, and from the bottom it's going to be a/2, and from here to the center of the interstitial it's going to be a/2, and same is true for the bottom unit cell. So distance between these 2 points is going to be a. Now, body-centered cubic structure, as we all know from previous questions, the atoms touch on the body diagonal. So if you draw the body diagonal for any of these structures, you will get a square root 3 is equal to 4r. So a equal to 4r iron divided by square root 3 is going to be equal to this length here. And what is that length? 1 radius of iron, 2 RFE plus our interstitial. That's going to be our expression to calculate the largest possible radius. That's going to be Ri equal to 2 over square root 3 minus 1 times RFE. This is 1.26 angstroms. So this is going to be 1.26 angstroms. And if you substitute that and evaluate this, you will get 0.1949 angstroms as the size of the interstitial.